So we're going to look at a section in our book now dealing with conic sections. And so conic section is just what it sounds like, a section of a cone. So what I've got here is a little diode, a little light source. And what I'm going to do is I'm going to cover that light source. And on the top of this box, you can see there's a hole. And so light emanates from its light source out in all directions. But with this box on top and the hole up on the top, the light's going out in all directions, but it's hitting the sides of the box and being absorbed by the black paint inside the box. The only light that's going to come out of the box ends up being a perfect cone. And so what I'm going to do is I'm going to show you how we can slice through that cone, in this case a cone of light, and get a number of figures, and that's what this chapter is going to be dealing with, is those resulting figures and the functions that result in those graphs that we would get from those. So I'm going to turn off the lights, and then we can see what kinds of shapes we get with this. Okay, so you can still see me, hopefully. So the light's coming out of this. Remember, that's the little light source there that I've got covered up. So the only thing that's coming out is a cone. So if I were to take a sheet of paper. Okay, so again, I've got my light source, and I've got my cone of light coming out of the top of my box here. Now I'm going to point it at this piece of paper, and you can see that that shape is a circle. So if I take that cone of light and I cut through that cone in a plane that's perpendicular to the center of the cone, we get a circle. Let me show you that again. You get a circle. Now, if I angle it in a slight way, you can see that the cone, the slice through that cone ends up being what you might refer to as an oval, but we'll call it an ellipse, okay? And then if I go a little bit further, you can see that the shape becomes a parabola, okay? Now, I'm not holding this paper perfectly planar, it's bowing a little bit, but you can kind of get the idea, I think. So it looks like a conic section that is a parabola. And then if we go a little bit further, let me put the box down if I can, and we get something. You notice here that the edge of the graph is a little bit more linear, and so that's something that is called a hyperbola. As opposed to something that's a little bit more curved, the edges of it are a little bit more curvy, and that's a parabola. But if we turn the plane a little bit more, the edges of that shape become a little bit more linear, and that ends up being at least half of a hyperbola. So that's the whole point of conic section, is that we get these functions from cutting through or a section of a cone. And so we call this chapter the conic sections. Okay, so we just saw how we could slice through a cone of light with a piece of paper. On the top of your notes, we have a demonstration tool in 3 dimensions. It's a website. I will create a link to this with the post so that you can open this as well. Okay, so this website has a pair of cones joined at their vertices, and it allows you to manipulate it around a little bit. So you can see this plane is slicing through the top cone, and you can see that it's perpendicular to the axis of the cone, and so that would be a circle. And then it allows you to change the angle of the plane that's slicing through, and so you can see it, and it's not super obvious. Let me go a little bit more. You can see now it is an ellipse. If we can, it's a little jumpy, but you can see now that is an ellipse. And then you can change the angle a little bit more. Let's try that. It's a little bit of a delay. That's still sort of an ellipse. Let's take it a little bit more. And so now you can see that it's starting to look like a, gotta get the angle just right. Yeah, that should do it. And so that's a parabola. And then if we take, you can see how the plane is cutting through. If we take and angle it a little bit more so that it cuts through both of the cones at the same time, now we get a curve that is a hyperbola. You can see the difference between a hyperbola and a parabola. You can see that as you go out to the outer edges here, they're very linear. As it turns out, it's asymptotic. We talked about asymptotes in an earlier chapter. So both of these follow a particular line called an asymptote. Whereas if we look at a parabola, let me get that angle back. Get that just right here. A little too much. Trying to get the angle just right. Okay, so there you can see that this isn't quite as linear out here. This will end up being more of a parabola. Okay, so let's look at and investigate the actual definition of what a parabola is. We've talked about parabolas in previous chapters, but we're going to go into them in much more depth now and utilize the definition to sort of create one in some software that I have. All right, so the definition of parabola is a set of all points in a plane that are equidistant from a given point called the focus and a line called the directrix. Okay, so this software is useful for drawing graphs, among other things. And so you can see here I've created an XY coordinate plane. I have a vertex V, I have a focus F, and I have a directrix. And so the focus and the directrix play a predominant part in the definition of a parabola. If I include a point here and I show the distances from that point to the focus and to the directrix, and we can see them here, that they are the same. And so I can move this point, and notice it's leaving a little trail behind tracing that point. But in every instance, in every location, the point P is equidistant from the focus F and the directrix D. And you can see that we get a parabola. All right, if I take it out further, you can see that this is going to be a parabola. All right, so how is the parabola useful to us in the real world? Well, one way that you're probably comfortable with or you've used is a flashlight. So if you take this parabola and you spin it about its axis of symmetry, it would create sort of a three-dimensional shape. And that three-dimensional shape is exactly what you see in the back end of the flashlight. Well, not the back end, but the front end behind the light bulb. And so if we had a light bulb at point F and the light is bouncing from that light bulb in all directions, some of the light will bounce off of the parabolic curved mirror or metal, shiny metal surface, and it projects it forward. So you can see that regardless of where I move the point P, the ray of light is going to come off in a parallel fashion going forward, which after all is kind of what we want a flashlight to do. We want it to take all the light from that little teeny bulb and project it forward in a particular spot that will help us see. Now, the reverse action is used when a satellite sends or beams an image down to your house. So here's the image coming, the wave or the signal coming, bouncing off of a satellite dish, the back end of a satellite dish. and it bounces off of that and heads directly to the focus point, at which point they have some sort of receiver that receives that signal and then sends it down into your television so you can watch TV, assuming you had a satellite dish. So the same thing for, it's basically the same thing as a flashlight, but working in reverse. So the wave comes in from the satellite, bounces off of the satellite dish, and is collected at point F, which is the receiver. All right, and of course, it's not a two-dimensional shape like this is. It's spun about the axis of symmetry, which I'm showing here, and then it's three-dimensional. Okay, so let's look at what changes if we change the focus and the directrix. So I'm going to take the point F, and I'm going to drag it closer to my vertex. You can see as I get closer to my vertex, the parabola gets more steep. The further away the focus is from the vertex, the wider my parabola gets. So every parabola that we've been dealing with in the past, whether it is sort of narrow or wide, has a focus and a directrix. We just never bothered to talk about them yet. And so now, today we're going to start talking about those different aspects of parabolas. Know that, of course, the distance between the vertex and the focus and the vertex and the directrix are always the same. So if I move the focus out, then the directrix is also going to move out. So let's get back to our notes for parabola section 10.1. So you see here there are two forms of a parabola. This is the one we're used to. This is the vertex form. Remember that h comma k is the vertex. A, the leading coefficient, is what determines the shape of this thing. We just saw that as this A changes and the shape changes, so does the location of the focus and the directrix on either side of the vertex. Okay, we also have a form that we've never used before, and this is x equals a y minus k quantity squared plus h. Now this is a parabola that opens up left and right. This one, the parabolas open up or down, depending on whether a is positive or negative. And here the same thing. When it's equal to x and the y is squared, it's going to be a sideways parabola. Obviously, it's not going to be a function in that case. But if the a is positive, it opens to the right. If a is negative, it will open to the left. Okay. So let's look at an example here. So this is in vertex form, so clearly we can write down what the vertex is. All right, that's going to be 3, 2, and you can see I've already plotted it here, and I've actually already plotted all these points for you as well. Okay, for a basic parabola from the vertex, we would go over 1, up 1, over 2, up 4. So clearly this is much wider than a basic parabola, and it makes sense because the leading coefficient is less than 1, and that generally gives us a wider parabola. Now, what's nice about this one is it's harder to graph these because you've got a lot of fractions, right? This isn't on a nice corner. You know, this one's not on a nice corner. And so there's a little bit of a trade-off. If we had a 1 here, instead of 1/4, then the points would be easy to graph, but the location of the foci and the directrix with respect to where the vertex is would be fractional. So there's sort of a trade-off. These are, when it's 1/4 in front, the points can sometimes be a little bit harder to plot, but sometimes the location of the foci are a little nicer. All right, so the focus. The focus is going to be above somewhere, right? So it's like a parabola, and it's you know, I joke that the fruit is in the bowl, so it's a parabola, and the F, or the fruit, is going to be inside somewhere. So it's going to be above. The directrix is like the table on which the bowl is sitting. Well, above the table, actually. So we need to figure out how far above the vertex, in this case, because it opens up, how far above the vertex the focus is. And this little formula over here helps us. So the absolute value of 1 over 4a, a being the leading coefficient, tells us the distance, and you notice it's absolute value, so it's the magnitude of the distance between the vertex and the focus. So for us, for the focus, we have 1 over 4 times a, and a is 1/4. And so I think you can see pretty easily that this simplifies down to 1. So that means the location of the focus is 1 away from the location of the vertex. Well, we know where the vertex is, and we know the focus is going to be above it, so 1 unit above. So this point is the focus. I'm going to plot it and put an F there. Okay? And so what is that location? Well, that location is just 3, 3 vertically, 1 above the vertex. All right, so let's go, while we're at this, let's go down and do the directrix. So the directrix is going to be 1 below the vertex. Remember, the vertex is here. Let me put a little V there. That's the vertex. And so the directrix is 1 below. So it is not a point, but a line. I'm going to dash it. That is my directrix. Let's label that with a D. And so what's the equation? Well, in this case, it's y equals 1 is the equation. Now, the axis of symmetry, that's what this one stands for, the equation of the axis of symmetry. So that's this one that the vertex and the focus are on, and it's like a little center line that we draw right through the center of that. Okay, so that's the axis of symmetry. And so what would its equation be? Well, it's going to be in the form of x equals, because it's vertical, so x equals 3. Okay? All right, so you should be able to plot the graph. You should be able to find all these missing pieces of information. Generally, we'll want to put it into the vertex form, and that will be helpful. Remember, too, sometimes we use negative b over 2a as the x coordinate of the vertex as well. So sometimes if we didn't want to put it into the vertex form like this, we could use this, then take this value and plug it back into the equation, and we could get the y coordinate. So another way of finding the vertex, but here you're going to find that we're going to put it into the vertex form, one of these two forms up here in our notes. This one if it's opening up and down, this one if it's opening left and right. Okay, so we can move on to this example number 1, graph and find everything. So in other words, find all this stuff for this function. So first, let's look at this. Is this going to open up sideways, or is it going to open up and down? And I think you can see that the x is getting squared, so it's going to be opening up and down. So we want to solve this for y in order to be able to put this into vertex form. So I'm going to divide both sides by 1/12, so that gives me y minus 1 equals, and I'm just, instead of dividing by 1/12, I'm going to multiply by 1/12. Instead of dividing by 12, I'm going to multiply by 1/12, and that gives me my my a value out in front. And then, so the last thing I want to do is add 1 to both sides, and you can see now we're in the form that we like, the vertex form, and plus 1. So the vertex for this thing is clearly going to be, remember, it's the opposite of this value. Up above, it was 3 because it was minus 3. So it's the opposite, including this value, the sign. And so this is going to be at -5, 1. Okay, so that is the location of the vertex. Now we need to figure out how far away the focus is. So the location of the focus, but in order to find that, we first have to figure out, well, how far away are the vertex and the focus. So we do 1 over 4 times, and then our a is 1/12. And so we simplify that a little bit, and so that's 1 over, and then when we simplify this, we get 1/3, or 3. Okay, so they're 3 away, but which of these numbers is changing, right? In order to get the focus to be 3 away from the vertex, but in the right direction. So we notice that this is, first of all, this is opening up or down, and it's opening up because the A is positive. So we are going to go up, up 3 from this point, and so the X will stay the same. The Y has increased by 3, so our focus is at -5, 4. Okay, now let's find the equation of the axis of symmetry. So don't give me a number here, give me an equation. So the equation of the axis of symmetry, it's vertical, we know, because this thing opens up. And so that's going to be x equals, and it's really just the x coordinate of our vertex and our focus, so that's -5. And now the equation of the directrix. And so that's going to be y equals. And so we are, it's horizontal, and it's 3 below the vertex, just like this was 3 units above the vertex, the focus. So now we're on the other side of the vertex, we're 3 below. So that should be an equation y equals -2. All right, so we want to graph this thing. And probably would be good so that we could make sure we graph all these things as well. It's the vertex is over here, so I'm gonna put the vertex kind of in the middle. Label that as the vertex, and then okay. So now where do my axes have to be so that that point is -5, 4. So 1, 2, 3, 4, 5. So this would have to be our y-axis, and we go over 1, 2, 3, 4, 5 to get to that point, and we would go up 1. So we're going to go ahead and put the x-axis here. So that's my x-axis. This is my y-axis. And so there's my vertex located in the right spot. Now, the focus is 3 above that, 1, 2, 3, up here at -4, -5, 4. And then the directrix is down here at -2. Okay, we can go ahead and put in the axis of symmetry. It's going right down through the middle. Okay, so there's my axis of symmetry. I'm using long and short lines for those. It's an engineering symbol that we use for center lines. So it's like the center of or axis of symmetry of the parabola. So I'll use long, short, long, short. It's just how we do that in engineering drawing. Okay, so so now let's plot some points. Okay, so now this one's a little bit hard. I mean, those were easy to graph, right? Those are nice whole numbers, 3 away, 3 away, those are easy. But the points to graph this is a little bit trickier now. So if I go over 1, normally I would go up 1 if I had a basic, but I'm going up 1/12 of that. So that's pretty hard to graph. So I'm going to go over 2 instead. So if I go over 2, normally I would go up 4. I'm going up 1/12 of that. So that's a third. I mean, I guess that's, you know, that's not too bad. It's a little bit easier, but still, you know, it's a little tricky. And so now what if I went over 3? I would normally go up 9. So so that one's a little hard to do. Let's try something else. Let's go over to 4. Normally I would go up 4. I would go up 16. So now I'm going to go up 16/12. So that's a little bit tricky to do. And then 16/12 reduces to like 1 1/3. So if I went over 1, 2, 3, 4, I'm going to go up 1 1/3. That's still a little tricky to do, but I think we'll try that. Over 2 over 4, up 1 1/3. Okay, and then if we went over 6, that one's a little bit nicer. So if I go over 6 for a basic, I would go up 36. 6 squared is 36, but we're going up 1/12 of that. So actually, that one's pretty nice to do. Let's try that. So over 1, 2, 4, 6, I'm going to go up 3. Let's see, 1, 2, 3. So I'm about here. And the same thing in the other direction. 1, 2, 3, 4, 5, 6, up 3. I'm about here. Okay, so you can see it's harder to get those points plot it, you know, finding the vertex and the focus are nice when this thing is really small, but trying to graph some of these points are a little bit trickier because we're dealing with a bunch of fractions. Okay. All right. Okay, so if we look at the next part of this, the table, it sort of gives just everything that we need to know, and sort of like how we can get these points. All right, now I wouldn't worry about necessarily memorizing this. Like, for example, the focus. I wouldn't necessarily worry about memorizing this. You're going to know that it's how it's oriented. And the A is going to say if it's positive, I know the focus is this distance above, right? If it's negative, then I know it's going to be this distance below. The focus is going to be this distance below the vertex. So I wouldn't really worry about memorizing all of this and memorizing this formula. Just know which direction you're going, and when you do your graph, make sure you go in the right direction, okay? Now, this last thing, LLR, it's one thing that we kind of skipped over. You might see it. That stands for the length of something called the lattice rectum. So the lattice rectum, let's go back up to our graph here. So there is a segment that is perpendicular to our axis of symmetry, parallel to our directrix, that goes through the focus and has endpoints on our graph. So this segment starts here at this point, goes through the focus, and ends at another point on the other side of the parabola. That is referred to as the lattice rectum. And the length of the lattice rectum is going to be related to this. So it's really just 1 over A. So the length of the lattice rectum is just going to be 1 over A. So you can see what's 1 over A, what's 1 over 1/4, it's 4, and the length of this lattice rectum is 4, okay? All right, and we can see, let's say we do it with this one. What would be the length of lattice rectum? Well, here is the focus. If we draw, this is the lattice rectum. It's a segment that starts on, goes through, and ends on. And I think you can see that that is going to be a length of 12, which is 1 over A, which would be just 12. So the length of the lattice rectum is 1 over A. We think of it as absolute value, 1 over A. If they are asking that, we're not going to emphasize that too much, but that's something you might see. Okay, so now let's talk about what the horizontal looks like then. So again, we have x equals, we saw it up above in our notes, A times the quantity of y minus k, quantity squared plus h. Now, be careful, the vertex is still h comma k. So when you pull the values off of this, it's not the opposite of h this time, it's the opposite of the k. The k gets opposite, the h does not. So the x coordinate is out here now, the y coordinate of the vertex is inside the parentheses. So the y is always with the y coordinate of the vertex, the x is always with the x coordinate of the vertex inside. So that's the only thing you got to be careful. Don't always just take this value and make that the x coordinate. In this case, the x coordinate is from outside. All right, the equation of the axis of symmetry. So now this thing is sideways, right? We're going to have a sideways parabola, and so the axis of symmetry will be sideways. So it will be y equals, in this case, it'll be y equals k. The focus will be the focus location. It's going left and right from the vertex, right, depending on how it's opening. So in this case, it's going to be the h, which is the coordinate for the vertex, and then plus 1 over 4a, and then of course if a were negative, it would make this negative, right, comma k. Again, you don't have to memorize this, just know that it's 1 over 4a away, figure out your orientation, and then decide whether you're going to add or subtract it to the H, like here, or to the K here to find the focus. I wouldn't memorize all these formulas. All right, and so the next one is the directrix. And the directrix, in this case, this one, it was horizontal. Now the directrix is going to be vertical, so it will be in the form of x equals, and it will be the same as the H, right, where the x value is, but then you're going to add or subtract from it. So starting with that, we're going to start with the H, and then we're going to add or subtract negative for A. And again, if the A were negative, then it'll be opening to the right, and in which case we want the directrix to go to the right. And so that would make this negative, would turn that negative into a positive. So it'll all work out, but again, don't have to necessarily memorize all these. All right, so it will go, it will open up to the right if A is greater than 0, and it'll open up left if A is less than 0. All right, and then the last thing, the lattice rectum, it still works the same way. Its length is the absolute value of 1 over A. Not that you will probably be asked that a whole lot, but that might be in some of your homework. Moving on to the back of our notes, page 2, we'll look at several examples and practice some of the stuff we did on the front of the page. All right, so we want to graph and find everything, and by everything we mean find the vertex, find the focus, find the equation of the axis of symmetry, and the equation of the directrix. All right, so by looking at this, can we say which way this is opening? Is this probably going to open up, down, left, or right? All right, and so the y squared, y is being squared here, so this is going to be a sideways parabola, and the a, we can tell already, the a 1/8 is positive, so this should be opening to the right. Okay. All right, so let's put this into the vertex form. So I'm first going to factor out a 1/8. If you remember, it's like completing the square a little bit. So this gives me a y squared. We've factored out a 1/8, but I got to factor the 1/8 out of the y, so that leaves me with 8y. I leave a space. I move that 1 over. I don't include the 1 in what I'm factoring. And now I want to complete the square. So I want to make this a perfect square trinomial. Remember, this has to be a 1 in front to make that easier. So since it's a 1 in front, it's half of this, which is 4 squared, which is 16. So I just added a 16. What do I have to do out here? Remember, I'm not doing it on both sides of the equation. I'm doing them on both sides of the equation, so I have to undo this 16. I do not subtract 16 because remember, this 16's true value is 2. So I added a 16 whose true value is 2. I have to subtract 2 out here. Okay? And then we're ready to write it in its vertex form. The a is 1/8, y plus 4, quantity squared minus 1. So that gives us a vertex. Be careful, what is the vertex? The vertex is going to be -1, comma, -4. So this is the h, this is the opposite of k. Okay. So we then have to think about what's 1 over 4a, and so, or the absolute value really of 1 over 4a. So that's 1 over 4 times 1/8, which is 1 over 1/2, which is 2. So that means the focus is 2 away from the vertex. And we know that it's opening to the right because it's sideways and it's positive. So my focus should be that way, right? To the right. So my focus is here, but 2 to the right of this. So that means I'm going to be at 1, comma, -4. The y coordinate's the same. It's the x that moved to the right by 2. All right, and the directrix. Remember, this is not a point, but an equation. So the directrix is a vertical line. It's the focus is 2 to the right of this. The directrix is 2 to the left. And so that would be an x equals -3, 2 to the left. All right, and then the equation of the axis of symmetry, that's going to be a y. It's going to be horizontal going through the vertex and the focus, and it's going to be at -4. Okay, so now we just need to plot this thing. I want to make sure I have room for my focus and directrix to fit on here, so can't put the vertex here. I want 2 away, so I could put the vertex here, kind of in the middle vertically. That means the directrix will be here, 2 away. That's the vertex. 2 away from that is the focus. The focus is here. Okay, and then we're not going to make a table. We're going to just graph some things. So I turn my thing sideways here, and I think, okay, I'm going to go a basic parabola. I'd go over 1 up 1. I'm going to go over 1 up an 1/8. That's too hard. I'm not going to try that. So if I go over 2, normally I would go up 4. I'm going to do 1/8 of 4. So 1/8 of 4 is a half. So I'll go over 2 up a half. I could go over 3, but that would be normally 9. I'm going to do 9/8. So 1 and an 1/8, that's kind of hard to do. So instead, I'm going to go over 4 from the vertex. Normally, I would go up 16. I will go up 1/8 of 16, which is 2. All right, so that's kind of a good, if you want to go over more, that's fine, but this is kind of a good place to start. And so 5, at a minimum 5 points. Also, you'll notice if we really wanted to include the lattice rectum on here, we could. It's just going through this part right here, so that would be the lattice rectum if we wanted to include that. All right, so we have the directrix, so let's label that as a D, and then we have, again, the axis of symmetry going through the center there. Okay. All right, let's move on then to number 3. Think about how this is orienting. Is it opening up, down, left, or right? All right, it's the y equals, and x is being squared, so this is a vertical one going up and down, and the a is +1, so this is a basic parabola that opens up. All right, let's put this into standard form, into the form we want, which is the vertex form. We have x squared minus 14x. I'm going to move the 50 over, and I'm going to add then half of 14 squared, which is 7 squared, or 49, and then I will subtract 49 out here. All right, so putting that then into vertex form, y equals x minus 7 quantity squared plus 1. All right, and so our vertex is going to be 7, 1. Now this opens up, so we need to find the focus. All right, so let's see. We have 1 over 4a. A is 1, and so this distance is 1/4. So this is a basic parabola, which will make the points nice to graph, but notice the focus and the directrix will be a little bit harder to find because of this whole, it's a 1/4 away. So we are above this point by 1/4. So if we're above this point, the y-coordinate stays the same. This goes up by 1/4. So if you want to say 1 1/4 or 5/4, that would work too. All right, and so now the directrix. Remember, this is opening up, so now we're a 1/4 below this thing, so it's up at 1, so we're at 3/4. So y equals 3/4. And then finally, the equation of the axis of symmetry, and that's going to be x equals, and it's the x coordinate of these two, so that is 7. Okay, so let's kind of put our vertex sort of in the middle here. Let's put it here. Is that good enough? No, I need to have 7. If I have this as the y-axis, 1, 2, 3, 4, 5, 6, 7, I guess I need to put it here. That way I can get my y-axis to show up. So there's my y-axis. That's 1 up, so this is my x-axis, so x and y. And then, let's see, the focus is a fourth away. It's so close you can almost can't even plot them separately. The directrix is at 3/4, so it's right here. Directrix. And then the plotting the points is easy. This is just a basic parabola, right? The A is a 1, so this is pretty simple. I go over 1 up 1, over 2 up 4, over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9 if I want to. Again, over 1 up 1, over 2 up 4, over 3 up 9. Okay, so we can sketch that in. Basic parabola like we're sort of used to from previous chapter. Okay. And then the axis of symmetry going down through the middle here. All right. And that looks about it. Okay. I just realized up here I didn't even put in my axis, x and y axis. That's probably a bad idea. I should do that. So this was at, the vertex was at -1, -4, so this would make the y-axis here. I should definitely have included that. And then we're down at -4, so 1, 2, 3, 4. This is where the x-axis should have been. Okay, always good to put those in. All right, moving on to number 4. Think about which way this is oriented. You may not know if the A is going to be positive or negative until we get it into the right form, but you should at least be able to say which direction it's going. All right, so let's put it into the right form. So, the y is being squared here, clearly. So we know this is going to be a sideways, but maybe we're not sure whether it opens up to the right or opens up to the left yet. Let's put this in the right form. All right, so first thing I'm going to do is I got to get my x by itself, so get rid of this -4. So I'm going to divide both sides by -4, so I get x plus 1 equals -1/4 y minus 2 quantity squared, and then ultimately I'm just going to subtract 1. So let me go back and just not have to rewrite that. All right, so x is equal to, and then here's the vertex form. Okay, so let's find the vertex. Careful of this one. Find the vertex. All right, that's going to be -1, 2. And so since our A is negative, we know this opens to the left. And so what is 1 over 4A equal to? That's going to be 1 over 4 times 1/4. Yeah, I mean, there's a negative in there, but we're doing the absolute value, so ultimately it doesn't matter. So this is going to be 1. Okay, so the magnitude of that is 1. So it's to the left 1. So the focus is, and so it's going to be 1 to the left, so the x-coordinate decreases by 1. Same y-coordinate. The directrix will be vertical this time, so that means x equals, and it is going to be to the right of this by 1, and so that means it's x equals 0. And then the equation of the axis of symmetry, we know that's going to be y equals, and so you can see it's the values that are the same in the vertex and the focus, so y equals 2. All right, and so let's get this graphed on here. We want, let's see, we want to do something, let's see, this is opening, you said, to the left, so let's do it over here. Let's maybe put our vertex right here. And then our focus is to the left one, and the directrix is to the right one. All right, that also happens to be the y-axis. And then the x-axis, these should be up by 2, so I'm going to move my x-axis down. And so here is my x-axis. Here's my y-axis. Also happens to be the directrix. So directrix, vertex, focus. Okay. All right, and so now what we can do is turn this sort of sideways. We know it opens to the left, and the leading coefficient of 1/4. So don't worry about the negative. We've already taken that into consideration. We're opening it to the left. So I go over 1 up 1/4, or over 2. Normally I would go up 4. I'm going to go up 1. So on either side. If I go over 4, I would normally go up 16. I'm going to go up 1/4 of that, which would be 4. 1, 2, 3, 4. And a total of 5 points for a minimum is pretty good. If you want to just do that, that looks pretty good. Okay, draw arrows at the end. That's always nice. And again, think about the lattice rectum. If you want to think about that, going through the focus, that distance is 4, which is the reciprocal of the a, 1/a, which is 4. So, okay. All right, now this example 5 is going in reverse this time. It is asking us to write the equation of the parabola given what the focus is and what the directrix is. So what I would suggest is just kind of doing a rough sketch. We know halfway between there is the vertex, so if we can figure that out, that would be great. The distance between them would be 2 times 1/4a. That helps. We could think of it that way. But let's just draw a little sketch. So we have -2, 3, so -2 up 3. So that is the focus. And the directrix is over here at 4. So something, I don't know, like that. And so this is 4 going over. And then this was 2 to get over here. So what's the distance between those? Well, that looks like 6, right? So the distance between them, 1/4a, would equal to half of that. So that would be 3. And so we can use this to find our a. But also think about, well, we know that it's halfway between, and so it should be about here, right? And so that location for the vertex is 1, 3. All right, so that's good. In order to write the equation, think about what do we need? We need to know the x and y coordinates of the vertex. We need to know the orientation, whether it's up, down, left, or right. And we need to know our a, right? So we've got our vertex. We can tell from this drawing that it opens up how? Yeah, to the left, right? To the left it opens. And then finally we can find our a. And then we have all the pieces we need to be able to write the equation. All right, so let's solve this. I can move the a up and the 3 down. So this looks like it's an a of 1/12. Now that's a magnitude, right? It's absolute value, so I don't know if it's positive or negative. I have to look at my orientation to decide what the sign is. And so, yeah, sure enough, the absolute value of a is equal to 1/12, but our a is going to be negative. So it's sideways, so it's the general form of x equals a y minus k quantity squared plus h. And so now we just got to plug in the stuff that we have found. The orientation, sideways orientation, told me that it was x equals and not y equals. And so now let's just plug in everything we know. So x is equal to, we've decided that it opens left, so this is negative 1/12, y minus, and then our vertex, remember this is the 3 that we're putting in here because that's the k. So 3 quantity squared plus 1. Okay? So that's sometimes they're going to give you an equation or some form of the equation, and you've got to put it into a good form so that you can pick out all your components so that you can graph it. Sometimes they're just going to describe where the focus and the directrix are, and you just know that the distance between those is twice 1/4a, so that distance was 6. Cut it in half is 3, so the distance that we know between the focus and the vertex, or the vertex and the directrix, should be 3. And that allows us to find our a, our leading coefficient. Okay, and so once we find the vertex, I would recommend drawing a little sketch here to help us find where the vertex is. Otherwise, without a graph, it's a little bit harder to figure out what the point is that's halfway between those. Okay.